Good day. An issue I'd like to address in this session is a redundant local administrative user. This user poses a larger threat than you would think and is normally ignored due to the lack of understanding and the real threats. Let's start by describing the redundant user and how it could have materialized in your enterprise risk portfolio. Firstly, a redundant user is a user that has been created for a specific reason, and this user is no longer used, and the best practice control such as password management is never or no longer applied. Unauthorized users may compromise an account, and then this is no longer seen as a redundant account and may be included as a valid account in your domain or your network, making your environment untrusted or non-trusted. Reviewing some accounts, depending on the operating system and the current version and service packs, I can focus here on Windows XP as an example, as it is currently one of the most prevalent operating systems used in the corporate or enterprise environment. Well, let's start by looking in a clean install from the CD and to see that a few accounts are created, and they are as follows. Firstly, the administrator. This is the first user created by the installation and has a SID or a security identifier which ends in a 500 or 500. This 500 is known as the RID or relative ID and cannot be changed. The SID consists of a random number generated per workstation as well as per domain. Even if the administrator name is changed due to audit recommendation, the SID stays the same. The user is the one that poses the greatest risk as a redundant user in your environment. I will go into a little bit more detail in the next section. The next user created by default has a SID ending in 501. This is the guest user. This user, as it should be disabled, is disabled by default. There is no reason why this user should be enabled in any environment, and we would like to give explicit access to any user which is created locally, if so and when is required. Some other users seen as well during the service pack installation is, for example, the help assistant, which is a remote desktop help assistant, and a support underscore with a number, which is a vendor Microsoft's account for help and service if required. Both these accounts are disabled by default and should not be enabled. If you have .NET installed, you will also see an account named ASP.NET, which is a normal user account where the password cannot be changed by the user and the password never expires. Now that we've seen some default accounts and some must exist like the administrator and guest, and some may or may not exist depending on the installation. Now if we look at the installation process, there's a few ways we can install a new operating system in your environment. This may be directly from the CD, usually not common, or a special build for a user, or we can actually use things like a disk image or cloning. The imaging process or disk cloning process results in elements that should not be the same on different workstations, and they may affect the performance and security of your environment. These attributes that need to be changed include things like the computer name, the security identifier of the user and the machine, as well as the driver cache. If this sys preparation or sysprep is not part of the installation process, you will have an administrative account with a different domain or workstation SID than the rest of the security environment. Okay. After the installation process has completed, using disk imaging or cloning, the following security anomalies exist. The first and most important risk that is created is the default administrator account with a default password assigned to a workstation. The risk discussion is where this becomes quite interesting and fascinating, as well as very scary if we look at it a little bit more deeper. How can users access confidential information or restricted data in your network without your knowledge? Well, let me discuss a scenario which shows this inherent risk. Right, the scenario is that we have a normal user with no special or administrative rights in the domain or at the workstation level, but have physical access to the workstation along with either a USB port or the CD or DVD-ROM access. That user can use a bootable Linux CD, which will give him access to the SID and the SAM or the security account manager, and either decrypt the local hash password or at least give me the hash of the encrypted password, which he can then write down, take home, or crack offline on another system using things like a public cracking website, and this can be done within a few minutes. A few minutes, you may ask. Well, yes. Normal brute force password attacks can take 30 days or longer on a normal environment. However, using applications such as rainbow tables, specialized software, which is freely available, encrypted passwords can be looked up. So this means that any password in your environment, if we have the encrypted hash, can be cracked in less than 5 minutes. Well, here at least we tell our users normally to change passwords every 30 days, but here we see we can crack a password within 5 minutes if we have access. Now, presume this user has cracked your local administrator password and the password is strong12. How can this be used to compromise another machine? Well, the easiest is physical access, whereby the unauthorized user will wait until everybody has gone home, and then you'll walk over gallantly to another workstation, log on as that user administrator and the local cracked password. Remember, the passwords are the same on all workstations, and this is your real problem. Now, after he's actually done that, he's got full access to the workstation. However, there are some issues we can investigate and show that the machine was compromised at a certain time. A larger risk is remote access to a workstation, which can be done from anywhere in the network, irrespective of the workstation is connected and joined to the domain or not. Consider this scenario. The internal hacker, call him user ID user 1, sits at his or her workstation user 1, working as normal. The hacker would like to access the director's workstation to obtain confidential files. Let's call the director's workstation director 1, and the director logged on as user 0. If the internal hacker just browses the network using the Explorer and tries to connect to the director's workstation, the domain will act as a security reference monitor and block the user 1, as this will be also logged in a security event log, either as 529 in Windows 2003 or 644 in Windows 7 or Windows 2008. And evidence will be there which user was tried and also from which workstation. Here we get to a point where it actually seems like it would be rather from a Stephen King novel, for example. The internal hacker performs the following step to gain access to the director's machine within minimal security event logging taking place as well. The internal hacker would do the following. He'll start a command prompt session and execute the following command. Net use star, giving the director's workstation name plus the share would like to access. Define a user he wants to log in as, but using the local SAM from the local machine at the director's level. And that is it. What will happen is a local drive Z, for example, will be remotely logged or assigned to the remote system. Right. So what can we do here? So once he's actually done that, he's got access to the C drive of the director, and then he can copy gallantly, as he with time at his hand, files in the temp directory to see what the user's working on now. His My Document and Settings folder, which contains all his personal work. Also things like copy the Outlook.pst or a similar file that contains all the copy of the email received, sent, and possibly deleted. Now what then? After the internal hacker has finished this job, he would like to make sure that he does not remain connected, and he'll use the following command. Net use Z, which has been assigned previously, /delete and hit enter. Now he's disconnected from the remote machine. Now the internal hacker is no longer connected, and he and she could copy the stolen data either to a removable hard disk drive and walk out with it. Another way of getting the information out the organization could include things like Microsoft Messenger or Google Talk, which allows for files to be sent out the organization. Access to webmail applications, not a good idea, may also be used to send company information out without any data leakage controls. Now, as you can see, behind this idea, this video clip, is purely to raise the awareness and the risk that there are some mitigating actions that we can take. And the easiest one is to remove those redundant users, identify every user in your organization and make sure they're either locked down or removed. If you have any ideas or want to discuss this, you can send directly information to us, and this will be followed up on a regular basis. Practice safe hacks.